Okay then, good morning everybody. I want to just start with the art giants are female slide, rather than putting it later. So this is an interesting one to me. This is Lynn Conway. She worked at IBM in the 60s, and while there did some important work in out-of-order execution in CPU architecture, which is a huge part of the performance that we have out of CPUs now. She was actually fired from IBM because she transitioned. She was a trans woman in the 60s, which was obviously not a good time to be going through things like that, I imagine. And so she started her career again in stealth mode, not telling anyone of her history. And whilst doing that, she and a colleague revolutionized how very large-scale integration designs were done that enabled, a lot of the advances in chip architecture, things like that we have now. So I wanted to pull that one up. There's some lovely overlap with the previous talk, which I like, and there's some going into the next one, so I feel very well placed. I wanted to talk today about my robot army. And this is a slightly excitable title for what is really about the automation that I do around my work to help me get out more software, get out more reliable software. So I've probably met an awful lot of you. My name is James McNally. I am an independent consultant. I develop performance and reliable measurement systems for various clients. It's worth being aware because it colours an awful lot of the conversation. I tend to work alone, although I have contractors in now and again working on projects, and I work with multiple clients, generally in kind of short batches of work. That's worth bearing in mind because I'm going to refer to that a few times through the presentation to kind of explain why some of the things I might do might be different, or why I haven't got around to some of the stuff I want to get around to. So in a lot of ways, I set out to really focus on technology, and I'm going to get to technology, certainly, but I realised so much of this is coloured by the approach, the workflows that you use with software, and how you want to do it. And I wanted to talk a little bit briefly about continuous delivery, and why it's something that has appealed to me, even as a solo developer. I'm not going to profess to be an expert in this. I'm not going to profess to be anywhere near anything that would be called continuous delivery. But really the philosophy here is kind of a bit of a guiding principle. And the idea here is at any point, if my customer rang up and said, by the way, that thing you've just fixed was critical for a customer, we have something that could be given to a customer to run, even if it's just a test. So we've heard continuous integration a lot. Continuous delivery and continuous deployment are the other terms that tend to come around. What I'm talking about continuous delivery is not continuous deployment. It is not we're pushing out a release to customers at every stage. But continuous delivery is technically we have an installer or an artifact at the end of each commit that could be given to a customer. Again, I'm not really anywhere near that stage, but that's kind of a guiding principle. The reason is there's been so many studies. There's something called the State of DevOps report, which is done every year, where they survey thousands of software teams and look at their practices and their capabilities. Capabilities is the wrong word. Their performance, essentially. How many defects get released, how many commits go wrong, how often they're able to release. And really what this shows is the DevOps practices and continuous delivery let you achieve higher speeds and higher quality at the same time, where that's normally treated as a trade-off, aka you can have your cake and eat it. So that's one of the reasons why this is a real kind of guiding principle for me in the way I've been working and what I'm trying to work towards. Because ultimately for me, it means I can deliver faster to my customers and spend more time on interesting problems. That's my personal drive. I like solving the problems. I don't like debugging things in production any more than I have to. I should say, by the way, I know it's a bit difficult in here. If you want to shout out for a question at any point through, I'm happy to do it like that, because I'm going to move through topics as we go. So I think an interesting question, although to be fair, this comes up less and less now, is if you're only one developer, why put the time and effort into some of these tools? And the first simple thing is I make mistakes. Like, this is one I hate to admit, because it happens way more often than I would like, is the number of times that I do a lot of test-first development, I run the tests, I write the tests for the bit I'm working on, I run those tests, and then I forget to run the whole suite before I commit, because my head's already moved on to the next thing. That happens more often than I'd like. Sometimes I replace my laptop, or need to share code with someone else, and by having these systems in place already, I can already pretty much guarantee you, here's my Git repository, you can get this running on your system. And I don't want to sit and wait for builds, or to be fairer, the bigger problem with this is I get distracted when I'm waiting for builds. And the amount of times, you've got an XE and installer build, so you get set off the XE build, and you're sitting there for a bit, and I'm just going to go have a look on the forums, and then you come back and realise that it's finished 20 minutes ago, and you've just wasted a load of time, and now you've got to start the installer, and the same thing happens again. So I do like the kind of automation aspect of just taking that out of my hands as well. I mean, I've kind of already spoiled this joke. To some extent, if you're looking for the perfect system here, I don't have it. This is very much a work in progress. It's a constant work in progress. And I know I fall short in certain key areas, which I will try and highlight as I go. But yeah, so the first thing to say, and again, this was nicely set up by the previous presentation, is fundamentally, these build servers are automation systems. Garbage in, garbage out is the good thought process here. If you don't have the good development practices in the first place that can be automated, doing them automatically faster is not going to make for better software. These are a few that I've picked out that felt particularly relevant to this. The first one is unit testing. I've stood up here many times and professed my love for unit testing. It makes my life a lot easier. It is very easy to automate, and obviously gives a certain degree of confidence that what is produced works. I want to emphasize, and I'll kind of come back to it later, this unit testing passing does not mean the software works, but it's a really good metric. I also believe very strongly in the mantra, make the change easy and then make the easy change. If you've never heard that before, try and internalize it, because it's helped me out so much. What that means in practice is when I come to make a change to the software, if it isn't obvious how it fits into the design, I want to refactor the design first so that it fits. And unit testing gives me the, I was going to say permission, that's the wrong word, gives me the ability to refactor in a relatively safe way, because those types of bugs are often quite easily caught by unit testing. The second one is documentation. Olivier's down here. You set me up nicely for that yesterday. I've taken the approach that anything that developers need to touch regularly should probably be in the repository. So in all my repositories now I have a documentation folder which contains, among other things, the user manual written in ASCII doc. And as I make changes to the software, I am updating the documents as I go. There's an underlying theme that I haven't called out explicitly in here, which is making changes and catching problems at the time that you're making those changes, so that you've got it in working memory, you're in the moment, you're in the zone, you know what you've touched. And documentation actually works surprisingly well for this. A number of times I think I'm done, and I put it down in documentation form. Like, there's an obvious gap here. It's kind of like explaining it to your user, but not actually to a user, but by writing it down, you're going through that thought process, and they're going to ask me if it does this when I hand it over, or they're going to try and do it like this and wonder why it doesn't work. So yeah, I really like that, and again, it fits this kind of model of continuous delivery, which is, you know, just changing things together in real time when you've got that idea in your mind, and then once this commit is done, like, it could be ready to go for a customer. The documentation is there alongside the code. So this has been one of those things where I always know it's a good change when I actually go back and change old projects to fit this, even though it's a pain in the ass. So someone said about ASCII doc to Word docs. I've done it the other way, where I've had Word docs for documentation, and I've gone, right, I don't want to be dealing with that anymore, convert it to ASCII doc, put it in the repo. The other thing I've called unreachable code here. What I really mean by this is just because code is in the repository doesn't mean it has to be user accessible. So this, for me, solves a lot of the problem of avoiding feature branches, because I know I can write a library. Let's say we've got an analysis library. I can write that analysis library. I can write the unit test for that library without integrating it into the main application, and I still have some testing, some work going on to prove that that works. I can integrate it and not expose it on the UI, and then when I'm ready for customers to see it, I can put it onto the UI. This isn't a formal thing. It's a hard thing to fully explain, and it may not work with certain types of features, or maybe in a bigger team you need something more organized, but this works well for me. And make sure, again, that my code is always buildable, always runnable. So I had to put this in as well, naturally. On the other side to this, we need tools to help us with the automation. I use Gitlab. Everything here should really apply to whatever continuous integration or continuous delivery environment that you use. I've worked on a tool called GCLI. I was trying to remember earlier, actually. I think that was about 2017, 2018 I started on that. That's available on the VI Package Manager. And what that does is it creates a proxy application and a library in LabVIEW that allows you to create tools that will work over the command line. So if you're automating software, generally the command line is the tool for doing that. A bit of a plug, there is a version 3 beta right now. It should be going as a release version very soon. I need to decide. I've rewritten part of it for a better architecture, and in theory it will support Linux, but I don't know yet whether I've got the time to get that into release. But if you're using an older version, if you want to go try that, I've been running it for a while, it's pretty stable, and I'm quite excited to finally get that done, because that's been not a lot of work, but I've spent a long time doing it. And then we need to automate the different tools that we've got. So my general stack of tools right now is App Builder. So I've got God, that is big when you look at it. There's no point in trying to point, is there? So App Builder, I've got a tool on GitHub for automating that through a CLI. It'd be lovely if NI could do that one day. I can't see enough to see if Eric's in the room. I've got a VI Tester CLI and a VI Package Manager CLI. That tends to be my kind of stack of tools. They're all available on GitHub. I haven't polished or published them as much as the rest, but I think other people use them, and I've been using them for years now without much bother. So that's kind of the tooling that I've developed around that. I know there are others. I think Crya, does it have a CLI built in now? Yeah. I still really want to experiment in Crya. I've just not got around to it. There's like things that are broken enough that you actually force the time to find it. Right now, VI Tester is not great, but it's not broken enough that I've actually found the time to look at Crya. So what happens when I check in code? So this is a job run. This is a screenshot from GitLab. As I say, don't worry too much about that. All of this applies everywhere. So I have 4 main stages. The first is a setup stage. By the way, I'm going to criticize this as a lot as I go, which will give you a general feeling for how complete I feel like this is. I have a setup stage, which is basically setting up the build server by running the VIPM API for installing packages and things like that. I don't love that as a separate stage. It works right now because I only have one build server for that, but technically it could break if I moved to like a Docker workflow or something like that. With better caching and stuff like that, I'd rather that happen as part of the test and the build stage. But that's, a story for another day. So that's what setup means. They're basically setting up the environment, installing any dependencies that are needed for the project on that build server. Then we move to test. For me right now, test is unit testing. To really get this to somewhere you could call it continuous delivery, that really needs more automated system testing and stuff like that. That's a bit more complicated. I'll talk about that a bit more later. The absent thing here is VI Analyzer. And it's funny, I nearly forget about it until I see Fab and York talking about it again. I did it for a while, and actually, funny enough, exactly as you said, Fab, it just pissed me off more than anything, and I took it out. It took way too long. I personally don't like the idea of running different configurations on different branches because, again, if this is going to break when I go to release it, I want it to break now. But the VI Analyzer stuff, I wrote some tools to run just the latest changes, which helped a bit. But it was taking such a long time, and like I say, it just didn't feel like it's valuable. I was ignoring it nearly as much as I was paying attention to it, so I took it out. I would like to get it back in there. In other languages, I do include a style checker in this workflow. So build is building the executables. So if it's a desktop app, I build the executable. If it's a real-time app, I build the executable. FPGAs, I've not included in this yet. I still build them locally and put the bit file in. There's some capabilities of automation. I know you've been working on this, right, as well. But it's a little bit more complicated than the app builder because it does it asynchronously on a server, and it got more complicated. For now, I skip it. I don't get enough value out of worrying how to automate it just yet. There's my docs. So this is where I take those document folders. So whereas all of these run on my own build servers, the documents folders can actually use a Docker image, which fires up ASCII Doctor and runs it through that. And then the thing I've always been a bit unsure about is including the installer in this process. And you know what? As I was practicing this presentation, I started out saying I'm unsure, and I've got more sure. So this is nice. I like feeling more sure about something. The hesitance is the time that it takes. You know, it's not a quick process. But I've actually countered that in my head with two things. The first thing is that, again, with that continuous delivery mindset, if a customer came to me and said, we want to see the latest version, I can give them an installer. And that's built, and that's there, and that's ready. The other side to this is the stuff that's really important about and most likely to fail is still happening quickly. So if this installer was a prerequisite to this, that would be more of a worry. But in reality, within 5 minutes, we probably got to here, and we'll know if the tests have failed. Depending very much on the project and structure, we'll be at build fast enough to know if the exe fails. So it's really still giving me that fast feedback, even though the overall time might be longer. And to give you an idea, it might be something like, I don't know, 20, 30 minutes for the whole thing. In reality, the common failures and the important failures are going to happen fast enough that I get that feedback quick enough and go, oh, crap, what was the thing I just changed? Which is what I really want to get to. So releasing. So this is where I do use branches. I like it as a way of communicating with my robots. Is the way I did it. I don't know. You may have seen I wrote a post on this for a while. So what I do is I do all my work on a develop branch. When I am ready to formally release it, so this is I guess, if the rest is kind of delivery, this is deployment. Just as has been said, we're not continuously deploying stuff because it's just not really possible unless you're doing web development. But what I do is I create a merge request to the main branch. I have a text expander template which generates me this checklist. I'm pretty sure I could do it in GitLab, I've just never got around to working it out. And so this is what I have to do manually when I want to do the release. So I make sure that the release notes are in the repository. So alongside the user manual, I also include a release notes document and a changelog. I do that manually right now as well. I know there are people who work on and are able to automate that from Git commits. Right now that hasn't been a priority. Make sure the version number and features are set correctly. I've mostly automated the features, but I have had this problem in the past where I will have a simulation mode behind a conditional disable flag, and then you send it to the customer and you've forgotten to turn it off. It's happened once, most notably. They were very confused why nothing that their hardware was doing seemed to be happening on the screen. So I have that as a checklist now. But mostly, actually, I automate this, and I tend to automate it as a pre-build step. I'd quite like to actually integrate into the LabVIEW builder tool that I've got the ability to say, by the way, set these conditional statements before you run the build. That would be pretty cool. System testing. So yeah, so the big thing I am missing from being anywhere near being able to cause continuous delivery is any kind of system level testing. So there is a brilliant talk if you search for Dave Farley go-to conferences on YouTube. He did a talk, I think, last year on continuous delivery pipelines, and he breaks it down really nicely about the kind of steps you've got to get through to be confident enough to deliver it. And there's a first fast step which needs to be, I guess, what you'd call continuous integration. That's your feedback to the developers. That's your unit testing. That's your merging it in, hasn't broken anything. We can still build the executable. Then you need some kind of functional testing to prove that the software actually does what it needs to do. And then you may have various other acceptance tests along the lines of performance testing, for example, or testing against hardware in our case. I have nowhere near the time nor budget to set that up. It is entirely possible. I actually taught a course at NI a few years ago, and someone on that course, their job was they basically did that for a product. So they had a software development team working in, I think, C or C++, because it's an embedded product. And what they were doing with LabVIEW was they were building a continuous delivery system where they would then be able to essentially perform like hill testing as part of the continuous delivery pipeline. So hardware does make this really hard, but it is possible. For me, it's covered by this checklist. It's hopefully I've done this as I've gone anyway, and I do have a check for individual issues, but I must confess I forget that one more often. So here it is. Have I fired up the latest build? Have I installed it? Have I run through and been happy with the system testing? Has the user accepted this test result? To be honest, I've needed this checkbox less than I've thought, because generally the users ask if they did it test. Yeah, okay, great. I've never had to provide too much proof, but I have it there. And another check that the documentation is up to date, because while I profess to try and be doing it alongside features, I won't claim I always remember. There may also be things that don't sit nicely alongside a feature. So for example, if the system requirements have changed, that may not naturally fit as part of the development work. So this is my kind of place to check on that. So this runs the release pipeline, which all the way to here is identical. So we're not doing anything different. The only difference at this point is that we actually publish what we've built. In my case, publish means putting it on GitLab. So for those of you that are familiar with YAML at all, this is the configuration. The top one is the publish, and that uses a Docker image with curl, which is like a HTTP client, to upload the artifacts to the repository on GitLab. So GitLab has its own place that you can share like packages and stuff like that. And then the second one uses the GitLab API to create a release in GitLab. So what that'll do is that'll pull the version that I've configured it will pull in, so I need a pointer, the description. I don't know if you can see on the end of here, description docs user changes. So that file that I've kept up to date will get published as part of that. And then it'll grab the installer and the user manual or any other artifacts that I want and attach those together. So I end up with an entry like this in Gitlab, which is my version, obviously the source code for that version, the artifacts, and then down here, this is the beginning of the list of changes in that version. Yes.
So you run a Docker image just to upload something on GitLab? Since you have a build server, would it be easier and faster to just run some LabVIEW code to upload on GitLab?
Sorry, I still didn't catch all that.
So as I understand, you run a Docker image to publish your artifacts to GitLab. Is it really worth it to run a Docker image for this simple task?
Yes.
Given that you already have a build server that could do that without a Docker image?
It could be, but to be honest, it's just way easier with Docker because I don't have to think about it. There's like an official curl image. It's still very quick to launch. So GitLab under the hood, when you're using Docker, caches the different Docker images anyway. And then it deals with moving the files.
What is quick to launch? Is it just a few seconds?
That's it, yeah. Because it's a distinct step. There's a certain amount of overhead anyway, so I think a lot of the Docker overhead gets lost in that. Even if it's on a build server, it would have to communicate down to it. And to be perfectly honest, like I want to spend as little time maintaining build servers as I can. So this way I know I'm always pulling like the latest curl and that's all handled. So yeah, if it was part of another step where I was already running on some kind of build server, then yeah, I would just do it on there. But seeing as we're going to pay the price of doing another step anyway, this seemed to be the easiest way to run that.
Okay, thanks.
There's a nice Gitlab API for LabVIEW available.
So Jorg has mysteriously remembered. So Jorg and Hamplesoft have been big proponents of GitLab. I think it's probably where I first came across it. And they have an API for the API parts of talking to GitLab in VIPM, is it? Yeah. So if you're working with that and you want to automate it through LabVIEW, then you can do that. Cool. Any other questions? So I'm going to talk a little bit about probably the thing that most of you wanted to hear about, but to be honest, it's probably the most boring part, which is the actual setup behind the scenes. So let me talk about what I like. What I do with other languages now is Docker is such a big thing. It's built into a lot of these things. You can just say, right, pull the latest Rust compiler Docker image and run it all in there. There are a few reasons we can't do that with LabVIEW. One is Windows is just less supported in Docker, but it is available, and Christian is somewhere. I won't even pretend I'll be able to spot you in that crowd. He's going to talk about that, I think, next. I'm very much looking forward to hearing how far he's got with that. So instead, what I do is I have a system running a virtual machine for each version of LabVIEW that is important to me. I may also end up doing one for 32-bit and one for 64-bit because there are some funny issues in LabVIEW launching and deciding between those two. And this has worked for me. So this is a big requirement, though, if you're new to looking at CI/CD stuff. Just be aware that of the different providers of technology, many of them will not support this. So most of the key ones will, most of the bigger ones will, but I'm trying to remember now. Like I think I looked at Circle CI, and if they only run their own runners, you probably can't do this. So like the Bitbucket pipelines won't let you do this, I don't think, because you can't run your own runners. So you're looking for someone who will support Windows and will support you running your own build servers. So if you don't have those two things, you probably won't get LabVIEW working with it. So this is the most expensive bit, I guess, from my perspective. This has been the reason to actually buy a server and run this there in the background. I just keep these running all the time. I think there are clever things you could do to spin these up as you need and spin them down. I just leave them on. Well, I say that. I can see two of them are off here. I'm not quite sure why. Normally, I just leave them on. And then I wonder why it stopped building because I turned them off. So this is quite important detail, and people have had success with different methods here. Because LabVIEW expects you to have a user interface, certain things are either only apparent if you can see the user interface, or require some kind of interaction. Now, the second case is improved a lot. So in GCLI, for at least the last few years, we automatically set a flag when we launch LabVIEW, which tells it we're running in unattended mode, and you should not prompt the user for anything, and it generally obeys that. The only exception I still notice is the licensing dialog, for, I guess, obvious reasons. So now everybody's on a subscription and not just as partners. You will have to log in once a year and reactivate it. But yeah, so many problems come, and if you cannot see what LabVIEW is doing, it is so difficult to debug it. So for that reason, what I do is, first of all, I set these servers to log on automatically with a user. That's the first prerequisite for this to work. It is a security issue. It's worth pointing that out. If someone else has access to this server, that means they are already logged in as a user. Chances are that isn't a big problem in most environments. If someone has physical access to a server, you're probably already stuffed. But it's just worth highlighting that. Depending on, it's fine when you can isolate the servers. If you are in an IT environment where you have to get essentially what you're doing is sharing a credential between lots of people. So they may not like that so much. And then what I do is I have an automated task to start the runner using the task scheduler in Windows. So at the login of the builder account, then run this. The alternative is all of these runs can be installed as a Windows service. The advantage of that is that it will run as soon as the machine turns on. So it doesn't require a user to be logged in, so you don't have to do the auto login, but you will not see anything that is happening. So, for example, the big case I have with this is when LabVIEW crashes for some reason. So because I have created the GCLI, I get the reports from people that say, I've got this weird error, and I believe, and I'm adding more logging to understand it better, a lot of these times it's because LabVIEW's crashed. But if you're not running it so you can see what LabVIEW is doing and debug it, it's very hard to understand why. I removed the other slide. And then, yeah, from there, it's just installing LabVIEW as you normally would on each of these systems. So in 2021, I think, NR added an official disclaimer into their license saying this is allowed, by the way. It's also worth saying. Before that, I think because it's technically a single user, I think you're okay anyway, but I think it was as of 2021, they've officially said, by the way, if you're using this for automated build servers, that's fine, you can do that. You still have to activate it with a license, but you're not in breach of anything by, I've essentially got 4 copies of LabVIEW that I could run in this kind of mode. So, I'm running out of time. I'm just going to give you my quick things that I want to improve on this, just to give you an idea that, I guess kind of as was said before, these are never finished, these workflows. The first one is I should really have build scripts in the repo so I can run them as a developer. Right now I do things manually as a developer and then automatically on the server. It would be good to have those scripts to make it easier to run locally, make sure they're running the same way, and even look at doing it as part of things like pre-commit hooks so I don't forget to run all the unit tests. So I need to have a play with that. I know that's a philosophy that others are taking. I know Hamplesoft, your wrap tool, does something similar, right? You can run it in the same way locally. This is something I really should have done by now, to be honest. I would really like to set up the build servers with something like Salt, which is an infrastructure automation tool. It's actually what is used in SystemLink for installing packages on remote systems. So I've had some experience with it before, especially now package managers are getting a bit better on Windows. In theory, I could attach all of these to Salt Server so that I can automatically make sure they all have the same version of Git, all have the same version of the GitLab runner, all upgraded. Right now, it's kind of as and when I remember to go check what versions they're running. And Docker, I'm going to, again, leave that as a nice tee up for Christian's talk later. Running these servers is a pain. I would love to just be able to spin up a Docker image to run these builds, run these tests. and not have to worry about the kind of overhead of managing each of these servers. And yeah, testing I've kind of already spoke to. There's different levels of complexity to this. I know I'll never get to the point really where I can fully say, right, I've built it, it's passed, it's releasable. There's always going to be some manual testing. But there are certainly improvements I can make in the middle there to run more system level testing. I know I'm going to call out Sam Sharp at Agilent spoke at some of the user groups in the UK that they've done with test automation with the Cucumber language and using Python, I think, to drive the LabVIEW UI, for example. Looking at that, using those kinds of tools in other languages. I've got one project where actually we could reasonably run some performance testing, for example, as part of this and identify if we've got regressions in critical parts. So, yeah, I'd love to do a bit more of that. That's probably a bit further out. And, I say this to be not too hard on myself either. In reality, the way my projects are set up, I have limited time and budget on each of these projects to really go into this. I think what I've got now is a brilliant subset of really big impact for very little effort because it's very consistent across projects. I can very easily make improvements across projects with those. But yeah, one day I'd like to spend a bit more time on some of this and and really get some of these additional bits running. So I think I'm out of time. I lost track of when I actually started, but my timer says I'm out of time. I don't know if we've got time for a few questions still, or...
Yeah, we could probably take one or two if they're quick.
Hey James, so in your continuous delivery pipeline, what happens to all of the build artifacts? Do you store them? Do you keep them indefinitely?
Yeah, so they get, what's the right phrase? I think cached into GitLab. I don't actually remember how long it holds onto them. It's never been too much of an issue. I think it's like 30 days or something like that. It'll keep all of them. And then the ones that get published, that published state is basically saying explicitly keep these longer. You can do things in the pipeline as well to say how long to keep them, but I've never played too much with that. And so far I haven't gone over my limit. So I pay for GitLab, so there's a certain amount of storage that comes with that, and I'm nowhere near that limit right now, I don't think so.
Awesome, makes sense.
That would be the other downside to the installers, to be fair. They're a lot bigger than everything else.
If we take this last one up here, and then...
Oh, yeah.
Thanks, James. A question about your VMs. Do you typically install DecMX as part of the process? If you've got a VM for 2015, but you need 2 different versions of DecMX, how do you deal with that? That takes an hour just to install by itself. So.
Yeah, so, you could end up with a lot of VMs. I, generally speaking, will have, for a given version of LabVIEW, I will try and, I will just bring everything to a standard version of the drivers. So I kind of have I'm going to say a standard install that I do on all my systems, which makes it sound a lot nicer than what I really do, which is roughly go through this, say, yeah, I use that, use that, use that. But, I have, generally all of these will have LabVIEW, RTFPGA, DecMX, maybe XNet, and yeah, what I tend to do is try and, essentially, I guess I wing it on that would be the right phrase. I try and keep things to a reasonable DecMX version. We'll do that on all my customers. The drivers, the nice thing with the drivers is I find the upgrade process is pretty, I've never had something break going up through DecMX drivers. It's a pretty mature thing. So yeah, that's kind of the attitude I've taken to that. I think if you had real explicit requirements and you did have different versions, the only way you could do it would be to have 2 different VMs. And I do have a case, kind of because of that, actually, to be fair, they've got a bit of a funny mix of drivers, but they're also the only customer I have using that version of LabVIEW, where I have a dedicated build machine for that customer. I'm trying to remember. Oh no, that wasn't because of drive, that was also because they wanted access to the repo. So it's worth saying, if someone has right access to the repo, you are giving them carte blanche to run whatever they want on that server. So that's another security aspect. So in that case, that customer wanted access to the server, so I built a separate server for them so I can isolate it from everything else on the network. So that was a tangent, sorry, but yeah, hopefully that answers.
Thank you.
I would suggest VM snapshots for this kind of variation. So you keep a VM for a particular version, and then you have snapshots for maybe different packages versions. That makes things easier, and you use less resources on your VM server than having another VM just for internal.
Yeah. So just in case you couldn't hear, Matthias was just saying you can use snapshots to minimize the overhead of supporting those different versions. Yeah, unfortunately, I'm still on Hyper-V, which doesn't do that very well. But I would not recommend Hyper-V starting again. Start with ESXi, and you've got a lot more options.
Matthias, did you find a way to switch automatically or programmatically between snapshots?
They are looking into it, but there are VMware ESXi API that I know using SSH.
Well, thank you very much. I will be around, and I will be in the I'm going to say Slack Discord channel if you have any other questions.